science, and engineering. And PSE is a specific applied version of chemical engineering that is applied to the conversion of biomass into things that make people's lives better. We love what we do. We embrace science and technology and engineering, and we are driving the photosynthesis machine, and we're driving it fast. And today, I want to respond to some of the questions that you sent in. And a lot of your questions are about what paper is, where it comes from, but also about sustainability. And guess what? Paper and sustainability go together like that. So I have a very exciting story to tell you today. And that story is about, can you see that? Yes? All right.
Yes.
All right. So what I want to tell you today is about paper and cellulose, a sustainability story. So we're going to talk about what is paper. We're going to define it, and we are going to say why it matters to you and to other people. We're going to talk about why it is the ultimate sustainability material, and we're going to talk about some key statistics and how paper is going to save us. So let's define paper first. I'll give you two different definitions. The simple definition, the technical definition, the touchy-feely definition. And the simple definition is it is a felted sheet of plant fibers. Plant fibers felted together like you make some sort of felt. But it's also comes from pulp. And pulp is a pile of plant fibers that happens when we disassemble wood or any plant material, but mostly wood, using chemicals or mechanical action. So we go from wood to pulp to paper. But let me give you the technical definition. This group is interested in STEM topics. The technical definition of a paper is a web, a three-dimensional web consisting of cellulose fibers extracted from plants that are filtered out of a water suspension, and then when they're dried, they form natural interfiber hydrogen bonds, and you can see those fibers hyperbonded right here. Paper glues itself together. You don't have to have a glue. Now, let me reinforce this. Paper was meant to be because it uses the two hugely abundant materials in our natural world, cellulose and water. Cellulose is a polymer covered with OH groups, which lead to natural hydrogen bonding, right? So some people say, can we make paper out of plastic or metal or ceramics? Nope, it has to be cellulose only. And that cellulose has to be formed into a web using only water. Not alcohol, not propylene, not ethanol, not butanol, not anything but water, because water's polarity sets up hydrogen bonds and its surface tension jackhammers the sheet together. The two were meant to go together. Now, what I really want to tell you, and I get excited when I talk like this, you have to understand that cellulose comes from the air. Cellulose comes from the air because right now those trees, which have just established their leafy canopy, are sucking carbon dioxide in, and they're combining it with water from the earth, and they're turning it into sugar, glucose, and then it polymerizes that soluble glucose into this structure you see at the bottom, which is cellulose, the most abundant biopolymer on the face of the earth. Ladies and gentlemen, paper in all of its forms came from the air. It came from greenhouse gases. Think about that. So while I'm getting excited, let me talk about the touchy-feely definition of paper. It is an intentionally engineered structure which we invented and that has contributed fundamentally to civilization, to human comfort, to its development. We would not be where we are today, and I'm not talking about a pandemic, by the way, if it weren't for paper. And each person on this meeting uses about 500 pounds per year. And I'm going to tell you, it's one of the most remarkable things we've ever invented, right? And in fact, we're going to call it the currency of civilization. Currency lets things happen. Like you have money, you have currency, you get to do things. Well, with paper, you get to do things. So it has proven to be invaluable to society. Why does it matter? Why does paper matter to you right now, to our world? Because, folks, paper is what makes us civilized. It allows us to have civilized behavior, and we're going to call those the C's of civilization: comfort and cleanliness, That's important every day, maybe several times a day. Convenience, plastic bags, paper plates, paper cups, all biodegradable. Communication, copy paper will decline, but lots of other communication papers continue to grow. And finally, folks, commerce. Without the corrugated paper box, Amazon does not work very well. Alibaba does not work very well. You might even be surprised to find out how much paper is in that cell phone buzzing on your desktop right now. So think about all the ways that paper is involved in your life every day. We make that, and we teach the engineers who go out and run the process that makes that happen. That's why our degree is in such high demand, and that's why it's so important. So let me stop for a minute. Let me look at Bird's paper-centric view of the world. Don't you find it interesting that when we take the world's most abundant natural biopolymer, cellulose, and combine it with the world's most abundant liquid, water, we use those two together to make a naturally bonded material, totally sustainable material that makes people's lives better. That's the paper-centric view of the universe. You won't hear that anywhere else, but right here. So how is paper going to be the ultimate sustainable material then? How can I define it? You folks are interested in sustainable materials. What have you told us? Your generation has told us, no, I don't want an ocean choked with plastic straws and plastic shopping bags. No, I don't want landfills filling with plastic that does not biodegrade. No, I am tired of short-use throwaway plastics that are going to remain in our environment. I'm tired of using a material that is recycled less than 20% of the time. Paper is our natural alternative. Why? Well, paper is sustainable. It is 100% renewable, 100% recyclable, 100% biodegradable, 100% human compatible, and the process we use to turn biomass into paper is one of the most complex and efficient in the world in industrial America. So let's take each one of those points. 100% renewable. A lot of you have been sold a bill of goods about what we're doing to our forests in the United States. We are not deforesting the United States. In fact, our forests are our biopolymer treasure. In other countries, their biopolymer treasure is under the ground. In the United States, our biopolymer treasure is on top of the ground in the form of forests. We have been intensively doing plantation and natural forestry enhancement since the 1940s and 50s, right? So wood is primarily the raw material for paper that doesn't come from recycling. And in the US, we grow trees 47% faster than we cut them down. Think about that now, 47% faster. We would be fools to deforest and get rid of the raw material we need to make things. A third of the US is still covered with forest, and 64% of North Carolina is covered with forest. Think about this now. When we bring a log into a modern integrated manufacturing facility, and out the other side comes rolls of paper, that process is 97% efficient. No other industry can say that. We call that the Kraft pulping process. It comes from the German word for strong. All the chemicals we use to take the wood apart, unglue it, to undo what nature did, we recycle those, regenerate them, and use them over and over and over again. And all the part of the wood, the bark, the lignin that holds it together, all the organic material in the wood that doesn't end up in paper is burnt as a biofuel in a massive boiler that generates bioelectricity enough to power 30,000 homes a day. If other industrial processes ran like this, we would not be where we are today. Paper is 100% recyclable. Look at those statistics. Of all the paper we make in the United States, 67% of it is not sent to the landfill. It is diverted, sorted, separated, sold, and put into recycled paper. And in fact, 37% of all of our paper and paperboard come from recycled paper. Those brown boxes that you get from Amazon, those brown boxes that things are shipped to you in, you slit that tape, you throw it in the recycle bin, 95% of them go around and around and around. And worldwide, 60% of the paper worldwide comes from recycled paper. It's 100% biodegradable. Cellulose is a natural material, and as soon as it goes into the earth, as soon as it touches water and bacteria and light, it begins to break back up and break down into glucose and monomer units. It's easily composted, and you won't find paper bags fluttering in the tree as you go down I-40, and you won't find paper bags and paper drinking straws in our oceans. You will not see a paper straw being pulled from a turtle's nose in the ocean. And it's compatible with humans. We can't digest it. We don't have that second stomach like a cow does, but it's completely benign to us. In fact, you eat a lot of cellulose every year in the form of thickening agents. All right, now think about that. That's the beauty of paper. Somebody has to know how to run that biomass conversion process. And those are paper science engineers. And NC State's PSE program is the biggest in the world, and we are #1. We are juggernaut. And we have one of the most talented incoming first-year student groups. And we have some of the most successful graduates, and we have the highest starting salary on NC State's campus. How about that? The highest average starting salary. Well, it's not stopping there. Because what I'm going to tell you is that if you don't want to be in a world choked with plastic, there's only one alternative, and that is the only biopolymer available in abundance enough and sustainable enough to replace plastic. Because where did plastic come from? It came from cellulose from millions of years ago. Oil is a pre-concentrated version of plant matter. So I'm going to tell you something. You call it a paper mill, but it is a biorefinery, and it always has been a biorefinery. And what I want to let you know is that everything you can make from oil and natural gas, you can make from cellulose. So let's think about this. People talk about the biorefinery. Well, what is a refinery? Well, it takes in a complex mix of organic materials and then breaks it apart into value-added product streams. This is what it looks like for most of what we use: polyethylene, polypropylene, propylene, polybutylene, nylon. All those come from oil coming from underground and going into a refinery, like you might see at ExxonMobil. And then they use a series of physical and chemical separations to break it apart into different kinds of things that you use a lot of every day. That's the petro-refinery. Now, why do we have to change that? And you know the answer to that. Here is what happens when we, in the carbon cycle, when we combine the burning of fossil fuels and deforestation activities, and not all of that gets absorbed by vegetation. 3.3 gigatons a year excess into the environment, which is leading us to our greenhouse gas global warming issue. Now, what if we change that? What if instead of oil coming into the front of this refinery, what if instead it was wood and corn stalks and wheat stalks, wheat straw, rice straw? What if it was agricultural residues? We still do the separation, but now we have a balanced carbon dioxide cycle because we're now harvesting a balanced cycle. We harvest the photosynthetic pathway. We take greenhouse gases out of the air. The tree does and makes wood, and we make paper and cellulose out of that wood. Now, wood consists of biopolymers made all from that carbon dioxide and water. Cellulose is half the weight. Hemicellulose, which is a shorter, fluffier version of cellulose, and then the lignin that glues it all together. And we also have some extractives like turpentine and some fatty acids. Here's what I want you to get excited about. We're changing the direction of our ship. Our ship has been steaming along on a hydrocarbon-based economy, and we're turning it so it goes to a carbohydrate-based economy. Old carbon and hydrogen versus new carbon and hydrogen. And what I'm telling you is that we know right now how to turn woody and non-woody biomass into fuel and plastics and structures and chemicals and pharmaceuticals. We know how to do it right now. I bet everybody knows the reason that we don't. If we know how to turn biomass into this stuff, why do we use oil? Why do we use natural gas? Money. Money, because it's much cheaper to turn this pre-processed stuff into the materials that we need. And it has helped us establish a good middle-class quality of life. So we've got to find a way to make biomass conversion just as cheap as hydrocarbon conversion. And in the paper industry, we've already done that because your paper is very cheap. We've been called the Saudi Arabia of carbohydrates, not of hydrocarbons, of carbohydrates. And this gentleman, writing in a very prestigious national journal, says, what's going on right now in your lifetime, in your career, is going to be just as significant as the staggering effects of the Industrial Revolution. It's going to be the second Industrial Revolution, because we are the original biorefinery. Biomass comes in and gets turned into all the things that people need or are willing to buy. And in fact, it's happening right now. This is the newest, hugest pulp and paper complex in the world in Äänekoski, Finland. And they don't call it a paper mill, they call it a biorefinery. And it's 240% energy self-sufficient. It sells energy, green energy, back to the grid. And I've got a link here that you can use to find it later. And in their process diagram, they show not just the production of pulp for paper, but also all these other things that are getting turned into products or bioproducts. This is the tip of a very big iceberg. I really want to go see this place. It's supposed to be remarkable. In fact, one of the things that they're talking about here under pulp upgrading is they have found a way to take wood fiber and make it spin into a yarn like cotton. Cotton is cellulose. Wood pulp is cellulose, but cotton has a scaly outer covering that lets it spin into a yarn, but cotton is very bad for the environment, really bad on the land. And now, if they can find a way to make cotton shirts, not out of cotton, but out of spun wood pulp, that will be a big deal, ladies and gentlemen. So here are the facts of life. You use plastic, and they'll tell you plastic gets recycled. Less than 20% of it gets recycled, and I've heard the number is as low as 7%. But 50 to 60% of the paper products around the world are recycled. It's a no-brainer alternative for your generation. Dream with me now. Dream with me about the transformation. Plastic straws, paper straws. And right now we have a project in our building to reinvent the paper straw so it never goes limp, never goes soggy, never adds flavor to your drink. We want to see the disappearance of the styrofoam cup as we know it, the conversion to a paper cup that has the same thermal resistivity and the same ability to hold complex liquids. And by golly, ladies and gentlemen, we just saw the issuance of the first paper water bottle, because this plastic bottle has got to go. We've got to stop using so many throwaway bottles, whereas this paper bottle is completely biodegradable. That's a dream right there. That's the paper revolution. And with that, I think we've got time for questions, and I can't handle that much chat, so one of you nice counselors or coordinators is going to have to direct questions to me.
Well, I did save a couple that I didn't know how to answer back in the chat. So someone had asked for, I think when you were talking about our forest cover, how do we account for the loss of old growth and hardwood forest when we're talking about our forest cover increasing?
First of all, old growth deforestation is never due to its use for lumber, timber, and paper. It is primarily around the world because of overpopulation and subsistence farming. You don't have to worry about the old growth forests in the United States. We did away with those about 150, 180 years ago. We deforested North Carolina back during the colonial days. North Carolina used to be covered with trees 10 feet in diameter. If you go to the Joyce Kilmer Forest up in the west of the state, you'll still see some of those. So the bad thing about old growth trees is we love them, we worship them, we want to keep them, but they don't absorb much carbon dioxide. It's the new growth that absorbs the most carbon dioxide. So when we do responsible plantation harvesting and responsible management of privately held forest land, we are actually causing more carbon dioxide to be pulled out of the air. Plus, If you laid one finger on old growth trees and said you were turning it into copy paper or toilet paper, that would be a death sentence for any corporation in today's world.
Okay, so another one was, can plant matter be refined and used, can be refined into be useful polymers in things like polyesters and polyamides?
If you give an organic chemist sugar, and glucose is a 6-carbon sugar, an aldohexose. Don't get me started. If you give an organic chemist a monomer like that with so many hydroxy groups, OH groups along its backbone, that chemist can make anything we need, including aromatic compounds, aliphatic compounds. So the answer is yes. We know how to turn cellulose into polyethylene, polypropylene, but it's just much, much, much more expensive. And it's much, much more difficult to make the polymer behave like a couple of million years of pre-processing has tamed cellulose. Good questions.
I think I either answered them all back in the chat, or if you guys have any other ones, feel free to send them. And I will send some of the links that I put in the chat to Katie and Sarah, because there's some great resources. And when Dr. Bird was talking about the forest, one of the things I like to share with people is for our industry, 90% of our trees, our raw material, come from private landowners. So that's like someone who grows tobacco or corn or soybeans or any other type of agriculture crop. It just takes a lot longer to grow. So for the most part, that's supporting, you know, someone's aunt, uncle, grandma, grandpa, mom, dad as a farmer, essentially. So then, did you see that other question?
Where's that one? Okay. Will the paper, water bottles, straws be intended to be recycled or composted? I think those are going to end up either going out with the normal trash, where they actually will degrade in the landfill eventually, right? Whereas plastic won't. Or I think as the public puts more and more pressure, more and more people like Chipotle are going to take their paper plates and their paper straws and their paper water bottles and do their own regional composting, so they can tell the consumer your throwaway came back as plant matter. This revolution is going on right now. Now, before we run out of time, and by the way, Carlsberg, one of the world's most well-known beers, they have already perfected the paper beer bottle. Right? That's a big deal. So they're going to come onto the market slowly because they have to compete. And guys, what do you think is going to happen to all these products when oil is so cheap, minus $30 a barrel? Come on. And every time we try to put these bioproducts on the market, the global powers that are pushing oil are going to flip the switch, drop the price, and they're going to gut it. We were doing so many bioethanol projects 10 years ago. We were going to start up 3 forest residue to ethanol, fuel ethanol plants in North Carolina alone, 300 million liters a year. And about the time it got very, very exciting, the Saudis said, not going to happen. And they flipped the switch, and instead of being $180 a barrel, the oil was $50 a barrel, and it gutted every project. Your generation has got to put your pocketbook where your heart is, and vice versa. You've got to force your generation to embrace these new products and help. Come and join us. Get our degree. Help make it happen. And I'm going to tell you, bright young things, it's a good gig here. It's a good gig because we are producing outstanding young engineers. And when you get our degree combined with a chemical engineering degree in only 1 extra semester, we're going to say that you will have the tools you need to go out and make a big dent in the world of sustainability. Now, so without Jennifer would be disappointed if I didn't give you a shameless plug. We give away $300,000+ in scholarships every February. We have almost 100% job placement, and every day we smile about the role we play in the photosynthesis highway. Ah! All right. Any other? Yes, I'm just looking at the extra project. Yep. Well, thank you for your time, and I sure appreciate it. And of course, they'll give you contact information where you can reach out to us. But wow, would I love to see some of these smiling faces sitting in my first year class next year or the year after. I would love that. Okay, so I'll let Jennifer take it away from there.
All right. So you guys should have already been sent the materials and the instruction sheets and everything that you need for your activity. So what we're going to be doing is looking at the strength of paper the best we know how, where everyone has a common function of weight, which is going to be a cup of water. So one thing that's really important to Dr. Bird and I as we're educating the next generation of engineers is that you guys follow directions. So I am going to put sort of a little cheat video in the chat. I did it this morning super early and everybody in my house was asleep, so you might have to turn it up. But it just helps you visualize some of the items that you'll be using. And a couple of things that are important. It's very important that you keep your area dry over and over and over, because if you get your paper cylinders wet, their strength is going to be compromised. Also, as you get to your bigger cylinders, you might want to do those outside, because it's highly unlikely that you're going to be able to catch the tub of water as this compresses at the same time. I could do it myself with the small cylinders, but with the big ones, do it outside, and then you'll have to move to a separate little location. You don't want anybody getting mad because you spilled what could be a lot of water all over the place. So does anybody have any questions to get started with the activity?
I do want to jump in and say the reason we're doing this is to show you how remarkable paper is. It has a ridiculous amount of strength for its weight and its thinness and its flexibility. That is the sound of hydrogen bonding. And kids, on a strength per unit weight basis, this is stronger than steel. We have a test. See, can I get an amen from that dog? We have a strength test called the breaking length, which takes a strip of paper about an inch wide, and then you pick one end of it up and pull it up in the air, so the strip's getting longer and longer and longer. And we measure how high it has to be in the air before it breaks itself. This breaks at 7 kilometers. Steel breaks at 3.5 kilometers. Strength per weight is stronger for paper than steel, and it's completely reversible. And today you're going to measure the strength of a column of paper, and you're going to be surprised at how strong it is.
Kilometers?
Yes.
Just making sure. I saw some of y'all's faces. And someone had asked earlier if you need a paper plate. Ironically, this morning we're out of paper plates, so I use the lid off of a Quaker Oats jar to have my area to balance my Tupperware container. So as long as it's something with some amount of rigidity, that'll be good to go. And then you can write down your results, because we'll plug some of your results with my results into a graph and kind of talk about what we found. And then Katie, Elizabeth, or Sarah, can you remind me what time we need to rejoin? And I'll stay on, so if anyone has any questions, they can pop back on and ask.
How long did you want to speak at the end?
Let's say, I think 45 minutes would give people plenty of time to do the activity at least once, maybe twice.
Pay attention to the science of what's going on, and what you're doing is actually an experiment in what we call paper physics. Paper physics, how forces and stresses are distributed in a column or sheet of paper.
Great. So campers, let's try to be back here by around 2:15. The video that Ms. Piercy put in the chat is the same video that I had in the announcements right before you joined here, so you can find it there. And don't forget to take videos of you doing this and take photos and send them to us in the regular photos and video channel. Are we good to go?
I think so.
All right, ready, set, go.